How is everybody doing? Hey, John. Hi, Nancy. I see Silas. How are you all doing?
Very fine. How about you?
We're doing great. We're doing great. How are you doing?
I'm all right, Silas.
Good.
There you go.
Good to see you guys.
Good to see you too.
Thank you, Nancy. How's Canada? Is it cold?
Huh. Very.
Cold.
We lost you. We can't hear you.
You can hear me? Can you hear me,
Yeah, I
Nancy?
can hear you, Migat.
Okay, cool. Hey, Silas, maybe you have an audio issue on your end? Today, this one will be like really brief. We don't have a lot to go on. So we're gonna give another maybe 2-3 minutes, then we get started.
Yeah.
Okay.
Hello, Mr. Migot.
What's going on, man?
I'm good.
Very good to see you. Is that John?
Yeah, this is John.
How have you been, John?
Things have been tough, but I thank God
Yeah,
half
where are
of
you
them
at?
have been sorted.
Where are you at?
I'm in Fangano.
Oh,
Nairobi.
no, he's in
I'm in
Fangano.
Fangano,
So
Fangano Island.
a
Oh,
lot of
I
things
thought Mfangano Street.
I know, Mfangano Island in Lake Victoria.
Oh, I miss Kisumu.
Oh, you been to Kisumu?
Yeah, I miss Kisumu City. It's the
We need to take
cleanest city in Kenya.
We need to take you to Kisumu, Nancy, permanently.
Yeah.
Ah,
Yeah.
I like the people who live around that lake.
All right, that's good, John. Did you hear that?
There is sufficient fish. You know, when you come over there,
Yeah.
automatically you will be eating the likes of omena, which is rich in phosphorus and calcium, and
Ah,
that helps in the development of the brain. That's why people from Kisumu.
there are good people in that place. So,
Yes.
starting with Migot, I think he's from that community.
Oh, man.
Yeah.
Oh, I'm actually from Tanzania.
Oh, Tanzania. Yeah.
Tanganyika.
Okay.
Close to Zanzibar.
Okay.
Yeah. Thank you, Nancy, for putting a good word for us out there.
Yeah, you're good people.
Thank you. Thank you. You been to Kisumu?
I've been to Kisumu.
Yeah, have you?
Yeah, I have. I'm
Right.
telling you, it's the cleanest city in Kenya.
Oh, really?
Yes.
How long ago was that?
Actually, 2019. 2019
Wow.
August.
Wow. Fantastic.
Yeah.
By the way, the outlook of Kisumu has really changed drastically.
Yeah, it is
As of
very clean.
2019. Yeah.
And also, I like the lifestyle of that, the particular people of that community. I like the way they live.
Nancy, that's good. That's very good, Nancy.
Mhm.
You know, when you say that, you make some people become very proud.
You should be.
Yeah.
Make us.
Nice. Some people are still coming in, so guys, don't worry. We're gonna give them a few more minutes.
Yeah, we can
Yeah.
give them a few
Yeah,
minutes.
maybe another 3, 4, 5 minutes.
Yeah.
Yeah, it's been raining over here where I am at.
Okay.
Yeah, so
A lot of snow in Canada. I'm confused if it's already winter or it's still fall. To me,
wow.
it's already winter.
That's serious.
But I
Snow,
hear
right?
winter starts in 21st of December, so it's still fall. There are a lot
Wow.
of snow.
Wow, that's fantastic. Changing weather.
Like we thank God over here, things are just okay. Like it's somehow it's hot here and the weather is just conducive.
Oh, in
Okay.
We
Fanga.
enjoy the breeze. Yeah.
Okay. Fantastic,
Ah.
man.
Nancy, you should come over here to Mfangano Highland.
Yeah.
It has got some good scenery to visit.
And I think I love fish. We call it fish, so that will bring me there. Fish.
You're welcome.
This is always good.
Great.
Yeah.
So how did I on the believe on Friday I had, was it Friday? No, on Thursday I was sharing quite a number of codes. See if people could do them.
Hey,
Anybody has any question on those ones?
me, I have a question in that. I tried to interpret it on my own.
Okay. Which one? Which part? Which one?
The first one that you said we create wait, just wrote it somewhere today and said I'll ask you.
That's the one you create a file and then you read from?
Yes, that one.
Okay.
And the nested dictionary. Maybe we can pass through that as we wait for people to
Okay,
join
okay.
officially.
Hey, I shared some, let me see if I can share this screen real quick so I can show you. I shared some stuff here. If you look on this screen, section 3, let me make it bigger so you can see.
Yeah, the file processing.
You see, today we're gonna be covering. We'll be covering from pseudocode, algorithm, and their examples, and then sequence selection and iteration. And then we might touch a little bit of functions.
Okay.
Depending on how things go, but I don't want to overload you guys. But I sent out something on file processing and pickling.
Yeah, I saw that.
So whatever I sent on Thursday is actually falling under file processing. But remember, before we touch on file processing, we talked about the basic operators and the core data types. So the dictionary is the dictionary, the list, and the tuple. I call it tuple, some people call it tuples. Depends on where you come from, but it's still the same thing, right? T-U-P-L-E-S. So we're gonna be, that question I submit, I shared should be covering core data types and a mixture of that with file processing. So when you read a file in reading mode, it's gonna be R, reading. In writing mode, it's gonna be W. I don't know if you got a chance to read into the file processing aspect of it.
Yeah, for me, I read it.
Mm-hmm.
And please elaborate on that part of I and W.
Or the I and the W.
Yes.
Okay, so when you do, when you're given a file to read, okay, when you're given a file, it's either to read, so you read from the file, the contents of the file. So that's the mode. So you open the file and then you read from that file. It's gonna be the R, the read mode, okay? But if if you have a file which you want to read on, you want to write onto, then you use the W mode for writing a file. So if I gave you a record, you say we are going to insert new records into a dictionary. So we write new records into the dictionary. But if you're reading from the dictionary, we read from the dictionary. So writing is using the W, reading from is using the R. And in the dictionary, this could be like I was saying, a directory. So the directory could be your name, could be your address, your phone number, your email. Okay, so we
Okay.
can get that information we read from. So if we were searching a file, let's say we're searching for an item in a file, we will have to declare that file in a read mode, the R mode. But if we want to append to, or we want to insert a new record, then we use the W for writing onto that file. Does it make any sense?
Yeah.
Okay.
Hello,
So these are the
everyone.
modes. Mhm.
This is Donald.
Go ahead, Donald.
Also for the read, when the restrictions are not given to everybody, it could be just a read file whereby you don't have access maybe to some restricted PIA records like the social security number, maybe the phone number or something like that. But if the access is given, maybe it could be read and write. You can do both.
Yeah, you can read and write. So you can open a file and then you say, this file I'm opening it so I can read onto, read from and then write onto it. So in our case, with the directory, the assignment I gave, it's gonna be, you have to search from, which means you're gonna read from it. So you have to read and then look if you have what you're looking for. So you search. And then if you don't have it, then you're gonna go ahead and read onto it. So it has to have a condition, the if statement. Okay. Nancy, did we lose you on that? Are we good? Are we good on that one? Did we lose you, Nancy?
I'm hearing you.
Okay. Are we good on that?
Yeah. I was writing something.
Okay, cool. All right, so.
Also, when you get a chance, you can take us through the Lambda concept.
Say again?
When you get a chance or we have more time during the remaining bit of the course, you can take us through the Lambda.
Through the lab?
Lambda, L-A-M-D-A, Lambda.
Oh, the function.
Yeah, the function. Because in your notes, it's only showing about the remove concept.
Okay, no problem. I'll do that. Sorry about that. Let's see here. Okay, so we are going to go ahead and get started. And like I said, let me go ahead and give you a quick rundown of what we are going to cover today, so that we'll be on the same page. Okay, last time we did the first session, and our first session was starting with Python programming basics. We covered the variable names, we covered the basic operators, we covered the core data types, we also covered the numeric data types. And then we also went into precedence and associativity. Okay, we also did the exception handling, like how do you gracefully handle errors and warnings. Okay, so here today, we are going to go into section 2. And this section 2, we are going to talk about pseudocode algorithms and their examples. Okay. We are also going to cover sequence, selection, and iteration. We will also talk about, if we get time, we'll talk about Python functions. And that's where we'll be talking about the Lambda functions. Okay. And if I don't know if we'll have enough time, but if we don't have enough time, I might need to squeeze another session next week on Saturday, so we can cover these two separately without exactly overloading. Since this three will be, I mean, this two will be a lot to take like in one sitting. Okay, for us being new in this area. So having said that, now the pseudocode, first of all, let me go back to pseudocode and then sequence selection. Okay. So when we talk of pseudocode, or we talk of algorithm, they pretty much mean the same thing. Okay. Any other detail in there might just be there, but in actual sense, they mean more or less the same thing. So I'm going to share my screen there. And then say an algorithm or a pseudocode is the same way you'd write a recipe or you write a program, but you give your description in simple English. Okay. So algorithm is like a procedure for solving a problem. So you give it a step-by-step procedure on how to solve that problem. Now, in terms of actions to be executed and the order in which those actions are to be taken. So in an algorithm, we merely talk of the sequence or the steps taken. Okay. Now, to solve that particular problem. Now, those steps are normally sequential, like one after the other. See, for example, we start with step 1, we go to step 2, step 3, step 4, all the way. And then there's an option whereby, what if we don't have those steps? Okay, we can't be going to step 1 and then meet a condition. And that condition is saying we can only do step 1. And then if we go to step 2, we have a condition saying, okay, enter your name and then enter your gender. And then step 3 saying if your gender is female, then we have to branch. So we throw a condition. That condition, we call it selection. And in Python, we use the if statement, okay, to fulfill that particular condition. So we say if let's say the age is this and the gender is that, then we have a condition. So we say if the age is over 18 and the gender is female, then we know she could be, we're gonna say she could be a grandma, or she could be a mom, or she could be a lady. Okay. Then we can say if the age is over 45 and she's a female, then she could be a grandma. Definitely she has to be a grandma, whether she has grandchildren or not, but that's the age of a grandma, right? Then you say if the age, let's say the age is let's say the age is 15 or below, but not less than 11, and the gender is a male, then we say this has to fall in the category of a boy. So that is selection. So we do the selection to help you execute a program. So we did the sequence from 1 to 2, those are in sequence. It has to follow certain sequence. For example, we cannot determine whether they are grandma or a boy unless we did the selection in the first two to get the age and also to get the gender. And then once we put in the selection, now we know this is a boy. And then we say, if it's a boy, then go back and print this. Print this again, print it again and again until it's a number of times. So the time when we say print again and again, that's going to be iteration. So we iterate. In program, we call it looping. So we loop. And in looping, we actually use the while statement, or we use the for loop statement. Okay. So pseudocode is an artificial or an informal language that helps programmers develop an algorithm. Say one day you get a job, okay, you work for company ABC, and one morning your boss comes to the office and say, hey, Donald, I would like you to help us come up with this program. So normally in that case, you don't just go ahead and get started. We expect you to draft some kind of an outline on what the program should be able to do. That draft, once you write it down, then you're gonna put it like, say you type it in such a way there whereby you know exactly the sequence of events. I would like to put the name, I would like to put the gender, and then I would like to branch to this one if the gender is male, or I branch to this one if the gender is female. And then if the gender is this or the gender is that, then I would like to go ahead and print this. If I print one, if it's one, if there are more than one, then I would like to print up to the number of people in that particular category. So we have selection, we have sequence, and then we have iteration. Now, in Donald's case, your boss gave you that information. You don't go straight to the computer and then start typing a program. You probably want to go sit down and figure out how you'd like to solve the problem. Solving the problem will involve putting down the pseudocode or writing down the algorithm. That algorithm could be very simple, informal English statement. Okay, say you want to cook rice. First of all, you look for a clean sufuria or a pan, and then secondly, you pour some water in there. Thirdly, light the stove or whatever you want to use for that. And then after that, you go ahead and make sure the water boils. Then you put oil, you put your ingredients in there, like if it's going to be spicy and all that. So that is a sequence of events. And that can be written. So programming is almost like writing a recipe. Okay. So in that case, when you do an algorithm, those are in words. But the cases whereby you may be requiring to do that in addition to putting what we call a flowchart template. The flowchart template will be in the sense that you have to make sure that whatever you have is going to be in diagrams. Okay, I'll show you here shortly what I mean by a flowchart template. Just one second. Okay, so we have pseudocode is a text-based detail or algorithm design tool. Okay, the rules of pseudocode are reasonably straightforward. All statements showing dependency are to be indented. Okay, this will include the while, the do, the for, the if, the switch. Those are some of the examples. Okay, so you come here, for example, say down here, if a student's grade is greater than or equals to 60, then we print we print pass. If the grade is more than 60 or equals to 60, then we print pass. Or else, okay, we print failed. So if it's less than 60, then we know this student did not pass the exam. So that's an algorithm. This one is not in any language. So algorithm is very neutral to any language. Okay. Now look, in the next one, we say we are going to set the total to 0. When you set that total to 0, that means we are actually initializing. So we want to declare that variable for, let's say, grade variable, but that grade variable, the memory location, we want to make it 0. So we initialize. So we say the grade equals to 0. So we set the counter to 1, set the counter to 2. So if there are 10 students, the counter will count up to 10 for each student, one time, second time, third time, until they reach the number of those students. Okay. Now, see here, while the grade counter is less than or equals to, for example, 10, then we input the next grade. And then we add the grade into the total. Now remember, the total, we initialized it to be 0, so we had to add it to that. So when we do that, we call it counter. When we set the total to 0, we set the total grade to 0, we are actually initializing the counter. Each time we say while the grade counter is less than or equals to that total, then we input the next grade. Okay, we add that grade to the total, and then we set the class average. So we know the average, we get the total, we divide by the total number of items, and then we print the final results there. So if you look on the screen, that will be a typical example of what we will call a pseudocode, or what we would call an algorithm. This is very important. I mean, you could be in a big team of programmers. When you have a new idea, there's always back and forth until you get it right. So when you have those back and forths, what you're trying to actually figure out is the flow of this program. How will the user be able to see? What are we supposed to put into consideration before we get started? How is the logic? How are we going to calculate, say, for example, the average? How are you going to calculate the total? You know, and I would like you to look at this in a deeper way. Like, it's not really a simple programming most of the time. It could be a very large project, but every person in that project is given something to do. But before you go your way, there has to be that person who is going to do the system design. So some companies, they have system design person who designed the system and then give it to the programmers. So an algorithm could be done by the system design person, and then they give you who is going to be the programmer. The programmer should be able to read and interpret what needs to be done. Okay. Some companies, it could be a very small companies. You could be the designing guy. At the same time, you're the programmer. But all in all, you really have to be able to understand what it is involved in doing this. Okay. So we go here, look at, if you did that, you can, if you understand this statement, number 1, number 2, you go to number 3. Now you say initialize the total to 0, and then initialize the counter to 0. So the total will be total grade to 0, and then total count, put it 0 again, and then input the first grade. While the user has not yet entered the sentinel will be like the threshold, the biggest value they can achieve. Say, for example, they're 100 in this case. And then you add the grade into the running total. So This particular statement you look on the screen can be interpreted in any language, any programming language. You give this to, let's say, somebody who's going to do it in Python. You give it to somebody who's going to do it, let's say, in C++ or in Java. They read it, it's in English, they understand it. You can derive any code out of this and be able to actually make it work. And that's a typical example of algorithm or the pseudocode. So it goes from number, you see number 1, number 2, number 3. You come to number 4. Each time you initialize, and then you get the next initialize whatever you put, and then you go to the next record. So if there are 10 people, you have to do that 10 times. If there are 100, you have to do that 100 times. And each time you have to do that, you basically get a total, and then you print out. So we keep on coming here, you look at that, you initialize it again, number 4, you do the same, okay, until everything is done. And then you spit it out, you print the report, or you print the record, and you're done. Now, there are certain things you need to note about pseudocode. Make sure your pseudocode is easy to understand. In this case, to your target audience, who's going to be the programmer, or who's going to be like a project manager, or who's going to be a designer somewhere down the road. It has to be simple and understandable, okay? It has to be easy, and somebody should be able to translate it into a computer or computing language, okay? Describe the complete process without leaving anything out, you know? Make sure you're detailed enough to be able to put it out there for whoever. It's almost like explaining the simplicity to a 5-year-old. So when they go in there, they know exactly what they need to do, okay? So describe the complete process, okay? Now, some of the examples here. This is a very typical example of a pseudocode, okay? You say add 2 numbers. Once you add number 1, first of all, get number 1, and then get number 2, and then add the 2 numbers. Once you add the 2 numbers, calculate the area or the perimeter of the rectangle. Simple pseudocode example. Or find the area and perimeter of a square, okay? Or find an area of a circle, okay? Or find the perimeter of a circle. So those are very simple examples of a pseudocode. If somebody was to give you this instruction and then tell you, I would like you to go ahead and come up with something like what you see on the screen, but I would like it to be in Python. Okay, so let me go back here and then go back to some of the program I showed you before. Let me see if I can share that screen. Bear with me 1 second. Okay, now let me go back here and then share that screen. Okay, so here we are talking of write a program that reads a text file. Okay, first of all, we know we need to write a program. The program has to be able to read a text file. The file is a list of contact details for people. Could be anybody in school, maybe in a church. It could be in a company somewhere, we don't know. But contact details for people. With each contact, you are given the name, the phone number, and the email address. Those three records. Your dictionary, remember, it's a file, now it has to be a dictionary. Should be a mapping from contact names to email and phone number for that contact. So we have to split three. We have to have the name, we have to have the phone number, then we have to have the email. Okay. Then we say your program should then ask for user input. Okay. User input in the sense that you are going to use file processing to process, read or write to it, but at the same time, we are going to create an interactivity in that program such that we are going to be asking for file input. The input should be a single name, like just put a name, could be, let's say Nancy, could be maybe Ruth, John, could be Silas, Donald, whichever name. You put that name, okay? The input should be a single name if the name can be found. If the name is found, that means anytime they put the name, the program should be able to put a condition to go search for that name. If the name exists, then it's going to be displayed. If the name can be found in the contact list, then the output of that name and the contact details for that person will be displayed in the output. Otherwise, if it does not exist, the program will branch and write this name. Of course, it will come back and ask for, let's say if the name does not exist, you'll ask you for the email and also the phone number. Then immediately give those other two details, then you should be able to write this new contact information into the existing file. So that will be appending. So when you read from, you can read records. When you write to, you have to be careful. You want to write as an appended record so that you don't delete an existing record by overwriting it. So based on this right here, this is a statement, okay? It's a question. You can derive from this question an algorithm or a pseudocode, step by step, what needs to be done. And based on that simple pseudocode, you should be able to come up with what you are going to do next, okay? Because you've already almost conquered the whole thing. Now you need to translate that simple English statement into a coding language which computer will understand. And that's the main thing behind what we're trying to do today. So let me go back here, okay? So if you look on the screen here, I hope I'm sharing the right one. Let's see. Okay, if you look on the screen here, we have pseudocode example. Okay, can you guys see this pseudocode example?
Yes, I can see.
Okay,
Yeah.
that's good. Okay,
Clear.
now whatever we have before the code, this is an English statement, equivalent of what I just showed you right a few minutes ago. Okay, but now in this one, we went ahead and also created a pseudocode from the statement they gave us. So you can say begin, always begin, and then you put the end. So you have to begin, you begin, and then you end with the end. But in the middle, we say, first of all, add two numbers. So in this case, it's going to be S1 and S2. And then when you add those numbers, where do we add them to? We are adding them to a sum. That sum has to be what we call a variable for total. So I'm going to go ahead and show you real quick how we can run this program in simple Colab in Python. Okay. right, so let's see this. Okay, so we say input the first number. Input number, enter number 1. Okay. And then we are going to enter another number. So input number 2. So you have to make them specifically different. Okay, so these are just entries. So we have to give them variables. So how can I give a variable here? Somebody help me. Tell me what to do. Is it correct? Is that correct? Is this correct, what I just did?
I think it needs the quote.
Where?
Number.
This
Number
one is a
one.
variable. The number is a variable.
Yeah. I
And this is a variable. So is this good? Can we try and see if this can work? Let's see if this can work. So let's go ahead and run it. Okay. So what do we need to do? We have to define a number. How would you do this kind of problem?
You can
Remember this?
define,
Huh?
Identity.
you can say like a variable is equals to input,
Variable equals to
a
input.
variable
So we say what variable? The number? Number
now
one?
number 1 is equals, yes.
Okay.
Then
Go ahead, Esther. Keep on.
then number 2
Okay.
is equals to
Number 2 equals to same
input,
Okay.
and then now the integer function
Integer function.
and enter number.
Okay. You're gonna need that. Okay. Good. Keep on going. Is that good? Is this good?
Yeah,
Okay.
I think so.
Okay. I think we're on the right track. Let's go ahead. If you're in doubt, this is what we do. If you're in doubt, go ahead and print this one, right? You print that, and then you say number. Let's run it. If we run it, it's gonna ask us. So there's something we did not do right. What is it?
Oh no, it's integer before.
Integer before the input. Is that good?
That's correct.
Is that good?
Yeah.
Okay,
Yeah.
let's try now. Okay, now we put that one. We enter. So we are good, right? Very good. So we go back to this one and then we copy that. Then for this one, you go ahead and do that. And then you do the same thing you just did. So instead of that one, okay, integer before input, sorry. Number 2, integer before input. So if we do that, then this one should also give us the same thing we're looking for. Same number 2. If we run that, then we're getting, let's say this one. So we're good. So now that we know this is working and we know that's working, so we go ahead and comment that out. And then remember they told us get 2 numbers and then add those 2 numbers. So here we are going to go ahead and say adding those 2 numbers, okay? Okay, now we added the 2 numbers. What are we supposed to do? Plus Now let's go ahead and print out. So if you were given a pseudocode and they tell you, get two numbers, calculate the numbers, get the perimeter, get the area and the perimeter of a square or area or perimeter of a circle, this is what we do. So of course you have to have the formulas. Okay, the formula of, let's say, a circle, let's say an area of a circle, 2 pi r, maybe circumference, pi r squared and all those. So this is a typical example of how you read a pseudocode, how you translate the question of a pseudocode. In this case, we had question. This question here, we had a question. We translated that question. Imagine we translated that question into a pseudocode. If we did that in a pseudocode, then we'll be looking to see something like this. Okay, we'll be looking to have something like this one here. So a good pseudocode will need to begin with the word begin and end with the word end. It will need to have like very specific information which can easily be translated by the programmer. So we have to make a pseudocode. These are the conditions. Okay, it has to be easy to understand. It has to be easy to translate, and the description has to be complete. Okay, so before we proceed, anybody has any question? Any question? Okay, I'm going to assume there's no questions, so I'll proceed. Okay. I talked of a flowchart. Okay. When I started doing programming, of course, we used to have flowchart templates, some plastic stuff with I don't know if they're still there, but I think I still have mine somewhere. I kept it for so many years. So in a flowchart template, this is what we are looking for, or this is how it should be. You begin, and then you always have to end. If you have a rectangle, the rectangle will always indicate a process. There's a box, there's a processing box, okay? Input will always, what is this? I don't remember the name of this.
So in those, I remember when you are doing those commands, it's like you are assigning a variable to you are assigning your variables when you're inputting.
Okay.
Yeah.
So say one more time, Donald. I didn't get that.
If I can recall my DOS.
Oh, in those, yeah, okay.
It's like you're inputting a variable.
So when
you're assigning a variable.
When you do those, that must have been, you're doing programming in those, you could have been doing auto batch file, right?
Yeah, correct.
Okay. So just like any other programming language, yes, you have to be able to have your variable and to declare your variables. In Python, you have to declare the variable, but you don't have to declare the variable type. If you go into, say, C++, and I believe Java and C#, you have to declare the variable and you have to declare the variable type. And there are types, several types. There's integer, there's float, there's decimal, there's so many of them out there. Okay. So in this case, this is going to be a pictorial representation of what your pseudocode is going to look like. That pictorial representation with all this, we call it flowchart. It tells you exactly the first beginning step the second, the third, and what we do in the third one, the fourth one here. So we take variable one, we put it on one, okay, we take the first variable, we look for a memory location available for it. We say this is going to be a number. In Python, we don't care, we just set it aside. In C, we have to say we need, let's say, this variable to be of this specific type. So since we're working Python, don't worry about C or C++ or Java. In this one, we say declare S1. Bring that S1, put it on the side, and then go to the next one, get S2. In S2, put it in another memory location. And then in the next step, we are going to go ahead and get the total of those two, but we are going to assign them to a third variable, which is called the sum. And that sum will now be right here. So whereby we'll be able to retrieve the content of that sum, like what we just did in our Python statement. Okay. So that's a flowchart template. I mean, that's a flowchart, of course, a diagrammatical representation of what we need to do. So we have another example here. This will now be very, very easy. You calculate the area or a perimeter of a rectangle. Okay, you have to get your variables first, and then with those variables, you do the calculation. With those calculations, you take whatever you get. If it's an area or a perimeter, then you have to store them in their individual variables. And then you call those individual variables to print out. Okay. Okay, so we have here the same pseudocode. You have to begin. Of course, it's a flowchart. Then we get the first variable, we get the second variable, and then we do our calculation here. A number we multiply by the next number, we get the area. That's a product. And then we get our perimeter. Perimeter will be getting the first plus the second, and then we multiply by 2 to get the total of the area around that rectangle. The area here will just be calling what we got here. So in programming, you can easily create a function, and then in here, you just call that function without doing it again and again. Again and again. So just do one time, and then you just call the function each time you need it. So in this case, we call the function area, call the function perimeter. Remember, we declared here, and then here we store them as functions. Okay. The same applies to the third one. Find an area or perimeter, we get the square. Of course, we do the pseudocode. Okay, that pseudocode is very helpful. So having said that, now let's go back here. If I was to ask you guys, hey, this particular problem we have right here, can you guys create a pseudocode for it before you do anything else? Say you read it and then create a pseudocode. So you write a program that reads a text file. The file is a list of contact details for a number of people. You don't care which people, but those people, they have to have a phone number, they have to have a name, and they have to have an email. Okay. Your dictionary. So the file has to be in a dictionary. Remember the dictionary? The dictionary is, what are the, first of all, let me ask, what are the properties of a dictionary in Python?
Stores keys and values.
Okay. Keep on going, Jacqueline. Remember mutability?
Oh, it cannot be mute. It's not mutable.
It's mutable, right?
It's mutable, sorry.
Yeah, so we can write onto it, and then we can also delete and edit. So that's the mutability. Remember, tuple or to play is not mutable. So we chose to use dictionary, which is good for storing the contact details of a directory. And then I say your program should run, then ask for the user input. Like we just did, we asked for the user input. Okay. We can say whatever Esther and the rest of you did right here, we can ask for the user input. In this case, ask for the name, ask for the phone number, ask for the email address. But when we get those, you can write those details into a dictionary. Okay, how do we write those into a dictionary? I think I shared here. This is a list. Now you see, for a dictionary, this is gonna come handy for you. You have all the answers here. This will come very handy. How you actually, if we were to print this dictionary, let me see if I can if we can run this real quick. After all, there's no programming class without typing your programs. So you have to be able to do this to actually see how they work. So I'm gonna go ahead and share that screen real quick. Then I will try that. Okay, so come in. All right, there. Okay. Check it. This is a dictionary. If you were to print the dictionary, you just go ahead and say print the dictionary. Print people. In Python 3, print statement is a function. This used not to be the case in Python 2 and below. So if you were to print that, you should be able to get that unexpected event. Let's print that out. So we get the original to be printed out. That's a dictionary. That's our dictionary there. So we are able to print the first and second. What if we just wanted the second? Let me see if this can work. Okay, you can actually individually go in and print just one particular individual character. In this way, character in the sense name, age, and gender. Now, if you look at what you see on the screen here, this is a dictionary. We're printing out, now we're printing out, but remember, this is gonna be a what? Can anybody help? Square bracket. So we're using a list. In Python, we're using a list to help us print a particular item in the dictionary. So we can do that, and then now we can say, print that. Get a print statement, then we print again. Okay, print that, and then we go ahead and say people. But this time around, we want to say, we want to print the second record. So we go ahead and print here, then we'll see how it comes out. Say you had a very large directory of people in Nairobi, you know, all businesses and everything. And then you look into your records using your dictionary in your Python program. You should be able to identify a business and then print it out. Specific business based on what you're searching for. That's where you'll be able to use specifics like this one. Okay. So in that case, if you were to do what we needed to do up there, then you'll be coming through with this particular design structure. Now, let me go back, share this other screen. Now, it's telling us we can also add elements to a dictionary. You can actually add elements to a dictionary because according to Jackish, they say it's mutable. Mutability means you can add, edit, delete. To play or tuple is not editable, it's immutable. So here we can actually add, right there, we can add using that. So whatever you see inside the list, number 1, number 2, or number 3, we call that one an index. That's an index. So whatever we are going to add will be the next index to the already existing indices. So we add 3. That's how we declare in Python. Dictionary will always have the query bracket, this kind of bracket here. Okay. To add a new record, we'll have to be able to use the list, which in Python almost like arrays. Okay. So we go here. I'll share my screen here shortly so you can look. Okay. So when we copy these people 3, we copy each and every people 3 will have to have an index to tell them where they need to go. That index will have to be common across the board, which is 3 all round. If you need 100, it's going to be 100 index for that. So this is 3. If you go to the next one, 4. The other one, 5, all the way. So when we run the above program, it will output the following. Okay, let's see what it does. So I'm going to go ahead and share the screen. And a different one, so you can see. So you come here. Okay, share the screen here. Okay, so when we come here, now we've already copied stuff. So we are going to go ahead and print the same thing like the one you saw here. But this one will have, we will be able to print the one down. Now remember, if we did what we did down here, and then we want to print it up here, the sequence is going to be out completely because the program can only see what came before. If you wanted to print number 3 here, if you did number 3 here, it might not print as much as this is already run. This will not print because, let's see, you never know. Let's try. It did not. It can only get you the first sequence, second sequence, third sequence. Now, if we copy this program, okay, we copy those 3, and then we bring it down here. All right. We try to print it down here, then we should be able to get something. Not yet. We need to add this one first. Let's see here. Print people 3. People 3 is not yet added. Let's see here. Okay. So we got rid of that. People 3. Okay, now we have it. Okay. It's very important that your program has to follow a certain sequence, sequential. And then after that sequence, then you can go to selection. And maybe if you need, you can go and branch. Now the branching is going to be selection process. If you go and branch, then if you need to repeat, then you'll be able to do the iteration, the looping. Okay. So you already have these notes on the screen, the one I am sharing up there. Let me go back here. Okay, so you see that those are typical examples of how you can actually put your program in pseudocode and how you can also put your program in a flowchart. Okay, and I also showed you how you can also add to a tuple, to a dictionary. And you can also delete, just use the word del to delete a dictionary. Of course, you have to be able to identify what you're going to delete. In this case, your identification number will be the index. The index number, for example, we have 1, 2, 3. If you wanted to delete index 1, then you have to delete del and then put that index number inside those square brackets to delete that particular item. So if you want to, remember this is a voluntary class, but I would really encourage everybody to try the program I shared on Thursday on how to search, display, and add onto a dictionary, and read from a file, search from a file, and also write by appending to that file using your dictionary. It will be a very good exercise for you. In addition to that, I would very much recommend, if possible, make sure you write the pseudocode for that program. When you do that, this is how you practice. Write the pseudocode for the above program. Okay, it's gonna be in caps, so don't think I'm shouting. So write the pseudocode for the above program, and then you practice. Of course, through practice, that's how you will always get to ask questions. If there's any question, that'll be a good time to actually get it answered for you. Okay. All right, let me go back here 1 second. Yep. All right. So how is everybody feeling about this exercise right now? We just did in dictionary and to place, and after assuming that you did something in file processing. Anybody? Okay. So so far that brings us to the end of what we describe as pseudocode algorithm and their examples. Not much be done, but a lot needs to be done in terms of you practicing. Don't be afraid to make any mistakes. And don't be afraid to reach out if you really need to get my attention. You can always inbox me. I'll be more than glad to help. Don't be afraid. No question is a stupid question. Sometimes I might be rough though. If it's too simple, I'll come out and ask you, did you try this? Did you Google that? Not that I'm mean, no, but I'm trying to challenge you. Hey, these are some of the things you can do before you burn down the house. Did you try this? Did you try this? Did you try the other one? If you did not try this other one, then we can work. And that does not mean that I will not help. I'll still help. But I also want to give you an impression there are other solutions if you look out there properly. Okay. So our next example Today we are going to talk about, we've already talked about sequence selection and iteration, but we are going to go ahead and emphasize that real quick. Okay. Feel free to jump in if you have any question. If you feel I'm missing something, it's a good time. Okay. So we said, like you say, you just saw the example whereby if you don't put your program and your logic in sequence, you're going to be having a terrible time. You cannot do a summation, or you cannot do a product, or you cannot divide numbers if you don't start by declaring them. You have to have them in sequence. So a sequence or step by step means that the computer will run your code in order, in a sequence manner, one line after the other, from top to bottom. It will take one line, then execute, then line 2, then execute, especially in Python, being, remember, Python is an interpreted language. So it takes, and even other languages which are compiled, you still have to follow the sequence. It's almost like, hey, when you make a recipe for cooking rice, you have to start from the basics. Before you start getting that rice ready, you probably want to make sure that you actually have the rice. Okay. Hey, is there a clean sufuria or a clean pan to cook it? Do I have gas, or am I going to use electricity? And is the stove working? Okay. Then I need to put water in the pan and then light the stove and then get started. That's a sequence. That sequence of event, you can also diagrammatically present it, and that's what we call a flowchart. If you want to put it in English, it has to be in an algorithm. So you put it in English, simple statement, make it very clear so somebody can also understand. Okay. After the selection, after the sequence, we have selection. Sometimes you only want some lines of code to be run, some lines of code. It's a condition. Okay. You know, for example, there are certain movies which can only be watched by people of a certain age. So we say if the age is less than 10 or equals to 10, then exit. If the age is greater than 10, then go ahead and play the movie. That's a conditional statement. Okay. So, which means sometimes we only want certain lines of code to be executed. We use a condition. Okay. Otherwise, you want the computer to ignore these lines and jump over them to the next instruction. So programming is just giving the computer instruction. Those instructions, they have to appear in a certain sequence. The sequence of events, they have to be in a certain way such that it's either a sequence, or it could be a selection, or it could be an iteration. Now remember, for a programming language to be a programming language, it has to have three things. Those three things, we call them constructs. The three constructs for a programming language to qualify as a programming language are, first of all, sequence, selection, and iteration. That's a loop. Okay. Now remember, in selection, we can achieve this by using the if statement. For example, if a condition is met, then line 2, 3, and 4 are executed. Those could be print statement, or we jump to the next line, or we just basically stop. Otherwise, the computer jumps to line 5 without even looking or executing line 2, 3, and 4 because of the condition, right? So here, it's a very simple conditional flowchart. So we say, we hit the condition, we say, if the condition is false, then we go ahead and end. But otherwise, we go to the next condition. So if the condition is true, then we do the next statement. Okay. So if you look here, this is going in sequence. First of all, we start, declare the variables, and then we read those variables in, and then we take all the variables we read and then put them in a variable which is going to be an output variable. Once we get those, and then we go ahead and print them out. Okay, that's the sequence. Here we can actually skip some conditions based on what we don't want. If we don't want, let's say, a 10-year-old or below to watch a certain movie, then we just skip and then end the program. Otherwise, if they say they're older than 10, then we go to the next condition. The next condition could be just condition to code right here, could be play the movie. So when you see a box like that, a rectangle, that means it's a process. We process that. Okay. Now, the next thing here is loop or iteration. Sometimes you want the computer to execute the same line of code several times based on a given instruction set. This can be done using a loop. Okay, there are two types of loops in Python. We have the for loop and then we have the while loop. Loops are handy since they enable us to have to copy the same lines of code over and over and over. So you can put a loop in a very simple statement, or you can put a loop in a function. And then you say, okay, if this condition is met, go back and call that function. Otherwise, go and do this other function. So loop will always help us. All boils down to you being able to control the program. Okay. So this is the loop. So we test expression, we say if it's false, go ahead and process the statement below. Otherwise, if it's true, then we go ahead and go into the body of the loop. The loop could be a while or a for loop. Okay. Now, in fact, every full-fledged programming language has to have the above 3 programming constructs: 1, 2, and 3. Sequence, selection, and iteration in order for it to qualify as a programming language. So if I say, for example, if you're working with the HTML, don't tell me HTML is a programming language. What is HTML? Anybody? What do you guys think? What is HTML? We use it for programming.
A web design tool,
Say one more time.
web development tool.
Okay, remember, program is also a development tool. So I would say HTML is actually a programming language, but on the markup side. It's not for programming, but we use it for markup. So HTML is a markup language. Just like CSS, which we call cascading style sheets, that's a representational language. We use it for layout of a website, but they lack what we call the loop. They might have the sequence. They don't have the conditions. Maybe to some extent, we might get a condition in the future or in some of them. Now that there's always things changing. And I think you can get certain things embedded in them like JavaScript to make it a little bit more like a programming language. But that does not mean it is a programming language if you embed JavaScript in it. Okay, so they are not fully fledged programming languages. So we come here, we say writing lines of code is almost like writing a recipe to help in instructing on how to prepare, for example, a dish. Take, for example, the below recipe on how to prepare Swahili pilau rice dish. Okay. First of
Yes,
all,
Mimikat,
go ahead.
can you kindly clarify what you mean by the statement HTML is a markup language? What exactly is markup?
Okay. HTML, you know the meaning of, okay, HTML is an acronym, okay?
Yeah.
Have you used HTML before?
No, I haven't, but I think I know what the acronym stands for.
Can you tell me what the acronym stands for?
I think it's a hypertext markup language.
Right there, you answered your question, right?
Yeah, but I don't understand the technical bit of markup.
Okay, markup is just like, you see we declare tags, okay? Let me go back here and see if I can show you real quick how the HTML is gonna work for us. Okay. Okay, we can say this is gonna be an HTML language, like markup. This is HTML. 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 Okay, and then we say, we don't want it to be specific like HTML5, it's just HTML generic. So we come here and then we say, okay, we say title. Come back to them. Okay, and then we say title. We can say title again. So we open and then close those markups. We're marking, these are the tags. And then we come here, we say, go ahead and say that's gonna be, let's say name. Okay, so Jacqueline. Okay, and then we come here and then we say, now go ahead and open the body that markup language. And then close the body and then put whatever you need to put in the body. Those are markup. We are basically represent, it's a representation of language to help us put things out there. I can come here and then say date. And then I could probably be using another language, but now since I want the date, I can just say today. I can just say today's date. And that language I'm using, I might have called it, let's say, maybe I call it PHP. Okay. And this just an example. So it might not even be correct right now. And this just for illustration. So when we say we can embed this programming language, of course, PHP is a fully fledged programming language. Now we are using the scripting language of PHP to call the date and put inside the HTML language, which is just a markup. It's helping us to mark up where we are going to display something.
Okay, clear. Thank you.
So just a bunch of characters with just tags. Okay?
Mm.
All right. Are we clear on that? Do you have any other question on that?
No, I'm okay. Thank you.
You're welcome.
Yes, we have another question. Hello.
Go ahead, Anthony.
Is there a difference between HTML and HTML5?
Okay, HTML has several, like we talk of Python 2, talk of Python 3. Okay, those are different versions.
Okay.
Now, HTML5 has new enhancements, which were never there in just HTML4. And those enhancements are to do with like validation. You can do quite a number of stuff. So yes, there's a difference.
Okay.
Okay. Did that answer you? Okay. All right. Go back here. Let's see. We're gonna go back into the main thing here. So we are trying to cook some rice here. We have to go to this recipe. The recipe is in a book somewhere, but okay, we got it. Okay. You know you cannot put salt before you even know where you're going to put the salt in. So we have to have a sufuria. A sufuria, we get 2 cups of rice, we put in there, and then we get ½ kilogram of meat. Of course, what kind of meat? Maybe we have to ground it, just be beef, for example. And then we take 3 sliced tomatoes. What size? We have to know. Okay, that's good. Take some garlic paste. What size? How much do we need? What amount? Then we take some ginger, ground some pilau masala, put some cumin, and then 8 pieces of cardamom and 3 sticks of cinnamon. That in itself has to follow a certain sequence. So when we reach, for example, number 12, it's telling us to get 4 to 5 cube potatoes we put in there. So how do we solve this problem? Okay, this is just steps. Those are steps of the ingredients we need to have. We have to be able to get ready. Of course, for me, number 0 is going to be the sufuria. And then number 01 is going to be probably the stove available. Or do we have the firewood? What are we going to use for cooking this? But we are assuming those are already there, so don't worry. Let's just make sure we have the 2 cups of rice. We have the ½ kilogram of meat. We have the 3 sliced onions. We have the garlic paste, ginger, grounded pilau masala, and all that. Once we have that, then we are going to go ahead and write our pseudocode. Okay, now this is going to be the steps. Boil the meat until it's tender. How many minutes? In a sufuria, heat the oil and add the onions. Okay, let it cool. Let it cook until golden brown. So you gotta be there to make sure that thing is mixed up. Then you add the garlic paste followed by the ginger paste and cook for about 2 minutes. And then you add the grounded pilau masala, and then the cumin, and then the cardamom, and then the cinnamon, and then cook for another minute. And then we add the boiled meat. We do that, and then we go to 6, 7 until we reach 10. Now remember, when you're done, you're done. So at this point, we are done cooking. It's complete. You probably want to let it cool down. In the meantime, you prepare so that you can get, could be dinner or could be lunch. So when you plan and do the same in programming, just like in following a recipe, you follow the sequence of instructions to achieve a goal. Sometimes in the same instructions, you may find yourself skipping. When you skip, that means it's a condition. What if you don't have some of the ingredients? Maybe you have garlic, but you don't have ginger. Then you just skip from 4, you go to 6. What if instead of oil, you don't use oil and you don't use salt, maybe due to some condition? You say, I don't use that. So exactly, so you skip 10, 11, but you jump to number 12. So it depends on, let's say you're cooking for somebody who has a condition, maybe high blood pressure or maybe some kind of diabetes and stuff like that. So that will depend. That does not mean that by the time you're done, it's not going to be a pilau. It's still going to be pilau, but it's going to be a light pilau, if you want to call it that. Okay? So sometimes in the same instructions, you may find yourself skipping, and that's going to be a condition. So use a condition if, and then you go else or else if. Okay? Either way, okay, that's still going to be there. So we say either they may not be necessary or they may be redundant. Okay? Now remember, you can put that program that way. You don't each time you don't have to call every stuff. You can put it in a function. So call that function pilau. And then every time you want to do some pilau, let's say in line maybe 20,000. You just need to call the function. Or this function could be a standalone program all by itself. Okay. But sometimes you may also find that you're yourself repeating. There are certain things you might be repeating. You don't want to do that. You just call the loop. Some steps. So you loop, you repeat some steps over and over to make sure you achieve the desired result. Okay. Okay, so selection statement will be in the program below, like here. So first of all, list my contacts in sequence, like your username, okay, your email address, your name, and your phone number. In Python, we just did that, and then you print the name, print the email, print the phone number, print the gender. Okay, that's good. What if you don't want to do that? You can keep all this in a function. If you don't want to type again, you can do that and then save them in a file, and then you just call the file like you're going to do in dictionary. Okay. So a program is not a good program until our program can interact with the outside world. How do we interact with the outside world? In some cases, a user inputs a statement. In our dictionary or in our directory thing, you'll be required to put some information. So you do the input. So when you do the input, you put it in, and then you also want to print it out so that you can interact with the outside world. So whoever is going to be using the program will know exactly what they're doing. So put in the name and then print out the name. If the name is correct, then proceed. The name might be wrong, then go back in and do it again. And that's going to be condition. So repeat again. Next one, repeat again until you get all the information in. In other cases, an input came in the form of data set. In our case, it's going to come in the form of a file. If you create a text file and then you read that text file will have the name, the email, and the phone number. You read it, and then when you read it, you want to be able to read it by making sure that it's in a dictionary. So in our case, you could be reading it from a database or from an Excel spreadsheet or from a JSON file. So this might not be something you're familiar with, but whoever is familiar with JSON file are JavaScript notation files, or it could be what we call CSV file. Those are comma separated value files. We'll deal a lot with those ones when we get there. Right now, just know they're actually text files. Now in Python 3, we used input prompt to accept user input, while in Python 2.7, they were using something else, which you don't have to know, but it used to be that raw input prompt. That will accept user input. As you can see, there are two different functions depending on the version you use. Okay, so like right now here below, we can say this is going to be a typical Python statement, number one and number two. We put the name and then we print it out. Okay, we put the name, we say the name is Nancy. And then you go ahead and print out that name. Then you give it some interactivity, like if you put Nancy, then you want to print out, hey, habari yako Nancy. Okay. One thing I would very much encourage everybody to do in these notes, don't just read them. Read and practice. Programming is almost like speaking an ordinary language. Make sure you read and practice. By practicing, I mean read and type them in and see what comes out. When you get an error, that is going to be a way of you learning. Hey, where did that error come from? What did I not type right? Okay, so it's very important to do that. Okay. So make sure that you practice this several times, like several iterations. Okay. So did everybody, I'm assuming everybody in this call, did you guys get to the point whereby you are able to work with the if statements? Silence is yes to me.
Maybe you can just give a brush.
Did you, John, did you read?
Yes, I read.
Okay, did you understand it?
Yes, but not really 100%. Actually,
Okay.
I have some idea. Yeah.
Where did you have any problem? What part?
Like I normally when you spend when you look at other programs when it comes to defining the if conditions, there is this one. In Python there is, they say else if, but other programs they say if else.
Okay.
Yeah.
So anytime you do an if statement, anytime you do an if
Yes.
statement, don't put else if unless it's nested. Okay. So if John is a name, okay, if John is a name, then we know John is a name. But what if John is not a name? Then print this, else print that. That's a condition. So we put a name, we ask the computer, put a name. And then if the name is John, then we know John is supposed to be a male. Else, John is going to be a female. So you only use L if it's more than John as a state, as a condition. What are the cases whereby you get nested conditions? Can you give me an example?
Who's there?
Can you give me an example? I'm going to put somebody on the spot. Ruth, can you give me an example of a nested condition, like an if statement? Maybe I try Nancy. Maybe Ruth is not here. Can you think of a situation whereby you have more than like an if and else statement, a nested if statement?
Maybe you first give us an example.
I just gave you an example, John. I want you to give me an example now.
Maybe it's when you're nesting more than two conditions within the same person, John.
Yes. So can you tell me how that will be?
Let's say we say if John age is greater than 20.
Yes.
He should be eligible maybe to watch a movie.
Correct.
Else, if it's below 20, then he should not watch it.
Correct.
And then you can give another condition. Is he a male or a female? If
Exactly.
John, the gender.
That's correct. So if you remember, Nancy, remember the program whereby we were asking if the age is this, then this is a grandma or a daughter or a son. If the condition is this, it's going to be a male or a female. That's an
Yes.
else. Yeah, that's exactly how we use it. Nested means it's gonna be a condition within another condition. So if statements in Python are control flow statements which help us to run a particular code only when a certain condition is satisfied. Okay. For example, we may want to print a receipt at the cash register. Okay. Print only when the credit card transaction is successful. Is successfully transmitted to the bank. Okay. So when a condition is true, then we can use an if statement to accomplish this in programming. Or you want to allow a user to access your website content if they are only 18 years of age. So that's a very simple condition. Now to Donald's point, we say John is more than 20 years of age. And you know, John is going to be a name which belongs most likely to a man. Okay. And then, you know, John probably is a college student, for example, at one point. Then those are three different conditions. Now, if you were to work with those three different conditions and you want to use the if statement, then the elif will come in. Okay. Otherwise, condition will be as simple as just using the else condition. If John is 20, then John can watch a movie. If John is 20 and John is not a college student, then John can watch a movie. Else, John cannot watch a movie. He cannot watch a movie if he does not meet those conditions. Otherwise, he can watch a movie if other conditions were actually there. Say you have more than other conditions other than the ones given. Then you can say, okay, he's not a college student, he's over 20, then he can watch a movie. Else, what if he's a dad? Okay, and other conditions. So we can say, okay, whatever the condition, then we can allow him, or we cannot allow him. So those are nested. Now, when you hear the word nested, means it's a condition within a condition, an else if within another else if. Okay. There are other control flow statements available in Python. Just say if statement, if elif, nested if. The syntax of if statement in Python is pretty simple and straightforward. Simple condition. Remember, I shared a very insulting book. Not insulting in the sense in real word, but the title is Dummies. That does not mean you're dumb.
I like that book.
The book is good, right, Nancy?
I like that book. I read it every day.
Yeah. If you want to understand the if conditions, you have to read and practice. Practice, practice, try again, practice. Keep on iterating, practice, until it becomes second nature. Now, everything you look around will just be conditions. In fact, if the weather is bad, then I have to drive. Otherwise, I'll take a bus. That means the weather, whether it's bad or good, you have to go to work. But that condition of you going to work depends on the weather. Now, the weather will dictate whether you're taking a bus or you're driving your own car. Okay, we can put some more conditions in there. You say, okay, okay, if you're going to work, okay, yes, you're going to work. Then, is the weather good? Yes, the weather is good. Then, you're just going to go ahead and take a bus. You're going to work? Yes, I'm going to work. Is the weather good? No, the weather is not good. Then you have to take your own car. Okay. Now we can say, okay, you can take your own car on certain conditions. So we basically drill it down. We say you can only take the car if the car has a gas and you have the key. Does the car have a gas in the gas tank? Yes. Do you have a key? Yes, then you can take the car. Else, you cannot take the car. Else, if, take the bus. Is that clear? Does that make any sense?
Yes, it is.
Okay. Okay. You see,
I
at
have
this
a
point,
question.
go ahead, Esther.
On the nested if. There's when you say about like when you have two arguments like this, when you can say is he male or female, and then the age. Now when you use like operators like and or instead of having said if, like which one is there a better way like between the two?
I don't know.
Like
I don't know if I got.
if you can say if he's male and
Okay. Remember
I
the.
can give an example.
Go ahead.
You said the first example for nested if you said if he is male, do this. Then again, under it you write if he is less than 20 years old. So can you say instead of having the two if statements, you say if he is male and less than 20 years old?
Yeah, you can do that. You can avoid, in other programming languages, you can avoid that, let's say, by using case statements. If there's anybody here who's worked with any other programming language, in Python, we don't have that case statement. But yes, to your point, Esther, you can use that. You can use those operators to actually make your work easier. Say you're dealing with John, and you know John is over 20, and remember it's and if both conditions are true, then that's going to be an and that's going to be one. And then you can say if John is more than 20 or John does not live in Nairobi, then that's a different condition. So it can be John does not live in Nairobi. Or if John lives in Nairobi and John is more than 20 years of age, then that applies to him. What if John does not live in Nairobi? Or we say John does not live in Nairobi and is not more than 20 years of age. So one condition we can compound it. And then when we put our if statement, it will help us a lot in terms of, for example, if it's raining, yes, it's raining, then take your umbrella. Okay? Is the weather good? Yes, the weather is good. Okay, what's the weather? Okay, what's the temperature? Okay, what's the forecast for the day? Then take your umbrella and then go use the bus. Okay, those are all conditions. So I really encourage you to go deeper into those aspects of it. It will help a lot. Okay. So here we have very simple statement. For example, we can flag. Flag is just like true is a Boolean. We can put that in like a constant flag. We just flag it to say true equals to flag equals to true. If flag equals to true, then print welcome. And then print to the largest Python class in the Sahara, right? So it's going to print it out. It's going to print it out. But the moment you say something different, let me go ahead and copy that so we can run it. We're soon running out of time here. We might need to do another session next week, next Saturday, so we catch up. Okay, let's see here. Okay, I'm gonna go ahead and create a card.
We have another schedule next Saturday.
We might. I'll
Okay.
let you guys know. Most likely, yes. So I can cover functions and classes. I didn't want to cover functions and classes today. After all we are going through, this is heavy in itself.
Yeah, it's actually deep. That's why I'm wondering
Okay.
if we introduce something else before we practice this, it might be a bit overwhelming for first-time people like Nancy.
Okay, Nancy, I got you. Now, you guys have to do me a favor. Read whatever you can read out there. Ask me questions. So when you come in, we are all together. Okay. Let me see. I'm sharing. Can you guys see my
Yes.
where I have those code example?
Yes.
Okay. Okay, now here we flag it. We say true. It's almost like, okay, it's true. Now what is true? We declare the variable true and we put the Boolean value in that true. So we say if flag, whatever the flag is, remember this flag is actually going to be, it's gonna be checking the relationship between the two. That means we take the word true, we put in the flag, and then we ask the flag, is true actually true? It's almost like, is 1 equals to 1? Okay, 1 equals to 1, yes. Then we continue. In this case, we say, if flag which is true equals to true, then true is true, then we have to print. So let's see if it does. So we actually print it. Now, alternatively, we can say false. What if we say false? Then we go ahead and do that. So at this point, it will not print anything because it's false. So it's a condition. What if we say false here? It will have to print it because it's actually the condition is met. Okay? Okay, so in that above example code, we are checking the value of the flag variable. If the value is true, then we execute a subsequent print statement. The important point to note here is that even if we do not compare the value of the flag with the true and simply put flag in the place of a condition, the code will just run fine. Okay, so the best way to write the code above will be, we just do that, say true, okay, just do that, and then instead of putting all this, just go ahead and comment that. So if we were to run this statement, it's actually going to work because it's a flag and it's true. So the condition is met. Okay, let's see why not. I'm getting a syntax error. Can anybody help me? Can I get somebody? I want to see people who pay attention. Somebody please help me. What do I need to do? It's an if flag.
In the if flag, there should be a full colon.
That's correct, Irene. Thank you very much. Okay, now look. Now what? Was that Irene?
Yes, yes.
All right, thank you. You guys are fantastic. You saved me from that chaos. So You can do the one we did before, but you don't have to put this one. You don't have to put that, let's say, true. That's redundancy. You can just put this one and then you comment out the rest, and then it's going to work. Okay. So by looking at the code above, which is this one right now, we understand now the if statement, how the if statement works. The out of the condition will either be true or false. If the outcome of the condition is true, then the statement inside the body of if executes. However, if the output of the condition is false, then the statement outside of that condition is being skipped, or it's going to be skipped. Okay. Any question? Yep. So that's good. Okay. When I started out with programming, this is what I did. This just how I approached it. Any new language, once you read the basics, try to spend a lot of time doing what you need to do to actually get it to absorb, get you to absorb it. And one day think of a project, start building that project. If you have a computer, when we were going to school, there were no computers like you guys have laptops and all. Buying a computer was probably equivalent to buying a house. But you guys nowadays have computers. Not that it was too long ago, no. It was just the other day, but things have really changed. There was no Google. There was nothing. You guys have Google. So look for a project like the one I gave you, but look for something which will be able to help you practice almost all the aspects of everything you learned. Take like a computer company, tech company, and then design, let's say, an invoice program or design a stock control program. And then see how it works for you. Utilize Google, search out there, and then see what you can do. Start here. Yeah. So this one is pretty much repeating the same thing. It's the same thing which I also sent you. So I'm not going to go into that, but I would challenge you. If you have not gotten a chance to read everything here in this document, then you probably want to see if you can get it all covered. Because it's very imperative that we are all on the same page. Okay. Say, for example, right here, if you look at my screen, you say number 42. If number is divisible by 2, that means the modulus is going to be equals to 0. Then we print it's an even number. Else, it's going to be, this is a typical, John, if you look here, this is a typical example of an else statement. But if you had some more conditions down there, somewhere down there, then you start looking to use a else if. Okay. And I think we did, let me see what Esther sent me here. This is love your agenda. This is a typical example. This one, if you remember that, we did not even have to use other than just one. So we say the age, what is your age? Okay, that's good. What's your gender? Okay, we got it. And then we say, if the age is less than 18.
Bigot,
Yeah.
I have a question.
That,
What is this Elif?
where?
The ELIF.
If else.
This
Yeah,
one,
that one that you're pointing, yes.
that's like else if. Are you there? Nancy, you're mute. Was that question from Nancy?
Yes,
Okay, can you hear me?
yes, I can hear you.
You can or you cannot?
I can hear you.
Okay, did you hear the explanation?
No.
Okay, you see the word if?
Yes,
You can see the screen, can you?
yes, I can.
Okay, and then you see the word else.
Yes.
So else if is actually these two combined.
Okay.
Okay, now you can only use this one if you have a nested if statement.
Okay.
Okay, see the age is less than 18. So we say if your age is less than 18 and your gender is, let's say, F for female, then we'll probably have to print, daughter. But in this case, we are saying if the age is less than 18 and the gender is male, then we know that has to be a boy. So it's gonna be a boy, son in this case. Else if it's gonna be a lady. We say else. But if we want to continue, then we say else if. Else if we call the same condition, but we give us a different alternative. So we say else if age is greater than, so it has to be the opposite of that, okay? Greater than or equals to 18. Remember, equals 18 or less than 18 are two different things. So we say here we have to say, we can say here less than 18, okay? It's a male, okay? Then it's a son. Then you can also print here. You cannot go to the movie. Don't even think about it, okay? Here for the movie. So no movie for you. So this could probably be different. You say, else if this one, then we know that guy is not gonna go to the movie. Else if it's gonna be a daughter, we also have to print the same thing. Hey, you can still be a daughter, but you're still young. But there's no movie for you. Okay? So we say, alternatively, if the age is greater than 18 and greater than 18 or equals to 18 and age is less than 65, then we know this has to be a male and this probably is somebody's dad. As much as he might not even have kids, but he has to fall into that direction of being a grown-up. So we can say, okay, now you're a dad, you can go to the movie. Okay, go to the movie. Okay, okay, you can still be a lady, but you can still go to the movie. So you're gonna be a mama. So you go to the movie. Okay. Alternatively, so we say else if gender, okay, the same gender is male, the same age, then we're gonna say the guy probably is a dad and happens to be over 65, then there's a likelihood that is a grandpa, or there's a likelihood that a grandma, so they can also still go to the movie. So I would very much recommend, if you did not do this, you probably want to go do it again. If you did it and you don't understand it, go back and read the notes. Every note I sent, including the books, you don't have to read the whole book. Go into that specific section and look at the examples they're using. And also, if you're completely not getting it, feel free to also visit like Google, look for the examples. If you need more help, I'm here. Anytime, just inbox me if I'm not available. I don't answer you immediately, but I'll sure get back to you. Okay. So I'm gonna go ahead and call this session over for now, but I'm opening up questions. Next Saturday, we will have another session. I'll cover functions and classes in detail. Do we have any questions?
Yes, I have a question.
Go ahead, Irene.
So do you run it the way it is, or do you define the age or the gender first?
Right now, it's gonna be defined up at the top. So if we run it the way it is gonna work. This was a program given to me, I think Esther sent it. So the only problem you have is probably the indentation as usual. So if we run it again, unexpected indentation, and then run it again, then we are good. So we say, let's say this guy is 8. Enter male or female. So we say male. Son, no moving. Okay. See how beautiful that's gonna be. If you can keep on doing this, this will give you some adrenaline. You know, that adrenaline rush will make you not even sleep. You just wanna go get some more coffee and keep on going. So let's say the age is 19. And the age, the gender is female. Most likely a mother, they can go to the movie. Okay. And then let's go ahead and run it again. And then let's say the age is 66. No. Okay, 66. Okay, you say it's a male, a female. This has to be a grandma. They can go to the movie. Okay, that's how the question works. So John, next
Yes.
I put you on the spot, my brother. So you really need to know when you come next. Don't even say, don't give me an excuse that you cannot come. So you gotta be here on Saturday. So I'll ask you the same thing. Did you do it? And then I'll give you a program to run for us.
Okay.
We are all learning, so don't be afraid, man. Don't even be afraid to make any mistakes. Okay, did that answer you, Irene? Did that answer you? Okay. Any other question? Anybody else?
Is it this Donald? Is it always a rule to put the begin and the end when you're using the if statements? Like this one, you didn't put the begin and the end at towards the end of it. You did say end to end the program.
What are you talking about in this program?
I think he's talking about the way we were writing the pseudocode.
The begin and the end.
Yeah, the pseudocode is it's a convention.
Okay.
So it's always a good idea. Like if I was to look at your pseudocode and I want to come out with, I'll be able to know where it's starting and where it's ending. So in your pseudocode, it's going to be a good idea to put it beginning, put at the end, and also in your flowchart. You probably want to do the same. So it really gives somebody an idea where the program actually starts and where the program ends.
Okay, but for this one, you don't need to put those two.
Which one?
This code, the code we are running right now.
Why would you put you're mixing up.
Okay.
This is a code. This is not a pseudocode.
Okay.
This is a raw code. You only do beginning. You can, okay, let me show you how you can do that. If you really want to, you can just do like this, okay?
Okay. Okay, you comment it out, okay.
Yeah, because otherwise it's not what something Python will be able to see.
Okay.
And say end. But you don't have to. But if you're doing the pseudocode, it's also a convention, but it's not a must.
Okay.
There are certain things which are almost like they're not rules, but they're good to have.
Okay.
Yes. Okay. That answered you, Donald?
Yeah, correct.
Anybody else? Any other question?
I think my questions will come in the group and to your inbox, most of them, after I go back and start practicing.
Read that book. I sent more than one book.
Yes, I saw them.
I sent more than one book, and this class, you guys are very, very lucky you got more than one book. If you read, don't read a book like from A to Z, but for this class, try to read some of the difficult. This section we're working on today is normally very hard to understand. If you get it down, the if statement, the conditions, and the loops, then it will be easy for you to get the functions of the classes. Then once you get the function of the classes, now going back to the basics of Python, like in section 1, like variable names, basic operators, the core data types, the numerical types, the precedent and associativity, those are the basic building blocks which will help you put your code together. Okay. Any other question?
I have a question. I think I did not understand what is a pseudo code.
Okay. So I'm going to give you a very simplified example. Pseudocode or algorithm, okay, are more or less the same.
Okay.
Remember the rice recipe?
Yes.
If you write down the recipe step by step the way they do it here.
Mhm.
So, are you seeing my screen maybe? Which one am I sharing? Give me 1 second. Okay, see, look here. Okay, see these steps?
Yes.
Those simple steps, those, if you were to do that in computer programming, that would be like a pseudocode. Simplified. Okay, and I think we also did some up at the top in the other. 1 second here. Okay. Now you look at your screen. Now you see this is a pseudocode.
Okay.
Okay, pseudocode is basically your statement but in English.
Okay.
But it has to begin and then it has to end, and then you do the logic. So in your dictionary, in your assignment which I gave you guys on Thursday, I want you to put in your name, your phone number, not necessarily yours, but a name, a phone number, and an email. You can even use a program we call Pickling, which I'll show you how to work with next Saturday. Use those 3, and then I can generate for you the records. Okay, and then from those records, you can actually be able to read or write from. Read to or write from. I'm sorry, write to or read from. But in this case, I would like you to be able to make sure that you do a pseudocode on that program with the file handling and the dictionary, the one I gave you. So a pseudocode or an algorithm is an simple English statement to give you the instructions on how to program or how to write a code. And this is an example right here. So for it to work for you, these specifics you have to make sure you have. These 3, make it easy to understand, make it easy to translate, and make sure that it's completely described, like the process is complete. Okay.
Mm-hmm. Okay.
All right. Did that answer you?
I think I need to read again.
Please do read, and if you cannot access the notes, then let me know. They all should be near Google Classroom.
Who writes the pseudocode? Is
Hmm?
it the user? Is it the user that writes the pseudocode to?
The pseudocode is written by either the programmer or the designer.
Okay.
Yeah, the user just uses the computer. Most of the time, the user does not know. So they're just using it.
Okay.
Yes. Okay.
Thank
Welcome. So you'll be talking like a systems analyst or a project manager or a computer programmer or a computer designer, project designer. All these names will come, but it depends on the company where you are. Some large companies have each and every individual for those positions. But most of the time, like small companies, the programmer will be the same as the designer. So you'll be like, hey, go ahead and design this. So I give an example, Donald. Your boss give you a project, and then before you start coding, you probably want to write the steps. That process of writing that step down, you'll be writing your pseudocode. The pseudocode will give you a step-by-step way of how your program is going to be able to be written.
A pseudo is like a sketch.
It's almost a sketch, but in English format.
Okay.
Yeah, like you see right here. So we begin number, then you can put number 2, number 1, then put the sum, then I'll put the number 1, I'll put and all that. So this, read this one if you can to understand it.
Okay.
Okay. Any other question?
Yes, I have a question.
Go ahead, Anthony.
I'm asking about, suppose you're getting the area of a area or perimeter of a circle or a rectangle.
Mhm.
How do you validate the length and the width such that you can they cannot fetch negative values?
Okay. So
Yeah.
I'm not sure if I understand your question. First of all, the area of a circle will never be negative. So if you are to evaluate that, make sure that whoever put in the number, you have to do what we call validation. So you say the number has to be 0 or greater than 0. And then you do the calculation. So of course, we know the area can never be 0. So you say the number has to be at least a digit greater than 0 or equals to 0 for both. An area of a circle, we know the formula is area of a circle, let's say pi r squared. We know the pi is going to be constant, 22/7 or 3.14. And then we multiply by the r. The r is going to be the radius. Now the radius times itself is going to be r times r.
So there is some code I've said in the chat. Probably, maybe you can elaborate where we validate the length and the width.
What are you talking about? Which one? Which chart?
There is some the chart. In the chart, I've sent the Zoom chat. The Zoom chat.
Okay.
I've sent some code, source code.
Okay.
Yeah, where do we validate? Which area do we validate actually? Which section do we validate the width and the length? Sorry, the height, sorry.
Okay, so let me see. Are you accessible to WhatsApp?
Yes.
Okay, let me see. You said you put it in the chat.
What he's saying is, you see where you are now, that code, there's another code ahead of it, where you're calculating the area.
This one right here?
Just go above.
Go down.
I think where you're calculating the area.
Okay. So right there, perimeter. You calculate the area here.
Yeah.
I think it's that one, yeah.
So ask me one more time. Let me see if I understood the question.
My question is, in the program, when do you after width equals float, or that, where do you start validation? Is it below the height or just before you declare the variables above there?
Okay, so your validation will have to be like, you have to put the number first, okay? And then
Yes.
you use the validation, you have to use the if statement. The if statement, remember the sequence. The if statement, you will have to say, if the number you just put in is less than 0, then go back and put the right number. So it has to be after you put the number. It's when you do the validation.
Okay.
Is that clear?
Yes.
Okay.
Thank you.
Thank you. I'm gonna copy what you just put in the chat, so I'll go through them. If I need to elaborate on anything, then I'll definitely share. Okay. Any other person, any question? Any question for me? Anybody? Okay. I'm gonna give you a count. 1, 2. All right, guys. It was nice talking to you, and thank you very much for taking your time to come and listen to me singing. I look forward to seeing you guys again next Saturday. We'll cover Python functions, and we will also go into classes and objects. So before you come, you probably want to brush on those just to be on the no side of things, so that you don't, it doesn't sound a little bit Greek, but I'm here to also help you. Feel free to reach out, okay? Now, thank you guys very much, and you have the rest of your evening.
Thank you.
You too.
Good morning.
Thank you too.
You have a good one.